Good afternoon, sir. My name is Abhishek Pitroda and my ID number is 24C097 and my group partner name is Shivam Prajapati and his ID number is 24C098. So our topic is microprogram control unit versus hardware control unit. So first we understand what is a control unit. The control unit is the brain of the CPU and all operation within the processor. Each fetches instruction from memory, decodes them, understand what operation is required, and then generates control signal to coordinate the execution of the instructions. Think like a conductor is orchestra without the control unit. The CPU's component wouldn't know when or how perform their task. Every instructions your computer executes relies on a control unit to direct the flow of the data and operations. Now we understand what is a hardware control unit. The definition of hardware control unit is used to fix logic circuits and Boolean function to generate control signals directly from the instructions of code. Now, hardware control units works how it's work. Control signals are produced through a combinational logic gates without immediately memory storage. Now, key component of the hardware control unit is first one is a decoder, next is a encoder, multiplexer, and logic gates wired together in a fixed configuration. Now, some advantages of hardware control unit is first one is a extremely fast execution, means no memory access required. Second one is a lower hardware cost of a simple instruction set. Third one is a optimize or for a specific instruction set. And next one is a predictable performance. Now some disadvantages of the hardware controller. First one is inflexible. Inflexible means difficult to modify and or new add a new instruction cycle. Next one is a complex design for this hardware control unit. Third one is debugging and troubleshooting challenges. And final one is next one is require redesign to instruction set changes. Now we understand a microprogram control unit. So what is the definition of a microprogram control unit? First is use stored to microprograms in a control memory to generate a control signals. Each machine instruction implement through a sequence of micro instructions stored in a RAM or ROM. Now, microprogram control unit work is how it is work. The control unit fetch a micro instruction from the control memory based on the current machine instruction, decoding each micro instruction to produce the required control signals. Now, a key component of a microprogram control unit is first one is a control memory. Control memory like a random access memory or read-only memory. Second one is a micro instruction register. Third one is a sequence generator or a address generator. And next one is a address decoder. Now, some advantages of microprogram control unit. First one is a highly flexible or modified. Second one is easier to design and debugging. Third one is a supports complex instruction set. And fourth one is a can be updated through a firmware. And next one is a consistent control signal generation. Now, some disadvantages of microprogram control unit. First one is a slower execution due to memory access. Second one is a require additional memory storage. Third one is a higher hardware cost. Fourth one is a more complex control. And fifth one is a memory access overhead. Now, next topic covered my friend Shivam Prajapati. Thank you.
So now let's uh, side by side comparison. So uh, speed is higher in hardware control and speed is lower in microprogram control. flexibility is low in hardware control, and compared to microprogram control, the microprogram control speed is microprogram controlled flexibility is high. Uh, Complexity is lower in microprogram control, and hardware control unit complexity is very high. Uh, let's talk about cost. Cost is higher in microprogram control because it's need control memory, and hardware control cost is lower compared to microprogram control. Modification requires hardware redesign in hardware control, and software and firmware update in microprogram control. Debugging is difficult in hardware control and relatively easier in microprogram control. Now let's talk about real-world uses in modern CPUs. So Intel X6 processors use microprogrammed control for complex CISC instruction set, allowing backward compatibility and instruction set extension through microcode updates. In embedded system, hardware control is often used for RISC architecture when instruction sets are simple and fixed, optimizing for speech and power efficiency. RISC processor, it prefers hardware control for simplicity and speed. Now, now let's talk about key takeaways. Uh, Here you can see this graph, and from this graph, we can say that hardwire control units are faster but less flexible, and while uh, microprogrammed control units are uh, more flexible but slightly slower, uh, and it depends on systems requirements. Here are some references and resources which we include in our PPTs. So thank you. And now we see implementation. Left, the input switches A, B, C represent the instruction which is decoded using 3 cross 8 decoder. At the bottom, a clock and a counter generate timing signal which are also decoded. Uh, these instruction and timing signals are combined using AND gates to procedure control signal C0 to C7. At each clock cycle, only one control signal become activate depending on the instruction timing. Since all signals are generated using hardware logic, it is very fast but less flexible as we uh, compare in PPTs. In PPT, now let's understand using in one example. So when instruction and timing match, uh, any of CI becomes one, which is showing control signal generation using hardware logic. Now let's implement this. So uh, start simulation, start animation, and now you can see here 000, which means C0 is activated, and we start clock, then uh, it will check all possibilities, and which is match, and instruction and timing match, then C0 is match. Now let's change this C A0, which this is A0, A1 and A2. So A2 is 1. So 001 which becomes 1. So C1 is 1. Uh, A0 and A2 is 1, and A1 is 0, then which is binary 101, and in decimal it becomes 5. So C5 is 1. So here is the hardware control unit implementation in DIDS, and now we talk about microprogram control unit. So this is the microprogram control unit is in combinational circuit. So here this counter generates an address which is given to the room. The room stores micro instruction and output control signal. Uh, so now we see room editor, and it represents a microprogram control unit where control signals are generated from a room using address input from a counter. At each clock type, at each clock cycle, the room output specific control signals step by step to execute an instruction. So, for example, when we start this, we see 01 is there. So, yes, uh, clock animation start, and then yeah, this is 01. After changing the value, it will change automatically. So this is the microprogram control unit. Thank you.